Well, hello, you geometry fans. This is Dr. Ewing, and I'm going to go through the construction of Theorem 2. Now, Theorem E2 basically says that if you have a line segment and a point, that this line segment can be duplicated with C as one of the endpoints. Now, what's important about this is the fact that we will not be using a collapsing compass. That is, we're just not going to measure a compass and make a mark over here. We're going to use equilateral triangle and circles to basically construct a segment that's exactly congruent to AB. Now, to start this, we're going to build an equilateral triangle. Now, equilateral triangles E1, so we don't have to go through the process of actually going through all the steps we know exist. Now, what I'm going to do is pick the point of the line segment closest to C, which in this case is B. So I'm going to pick my equilateral tool, and you'll probably have to do some circles to do this, but you'll notice that I do have an equilateral triangle. And of course, all equilateral triangles will have a point D. After you construct an equilateral triangle, now remember that means all these sides, B, C, and D, are equal, we're going to construct a circle. What we're going to do is construct a circle around B that goes through A. Now remember, this is the original line segment. Having done this, I'm going to create a ray. Now, according to postulate 2, I can extend any line segment. So because of that, I'm going to create a ray starting at D, going through B. Now you'll notice that it does hit our circle. Now as we look at this, we have line segment BF. Now we can create the line segment. Now so far we've only created the ray. You actually have to create line segment BF, which I will not do here. But line segment BF has got to be congruent to BA. Why? Correct. Radii of the same circle, which is this one up here. Having done that, I'm going to create another circle, and this other circle is basically going to be centered at D again, and it's going to go through F. Having done that, once again I'm going to create a ray that extends on the other side of our equilateral triangle, from D to C. Again, like in most of the constructions, we have just constructed two things, a ray and a circle, and we find the point of intersection of the two. Now this point of intersection is going to be very critical. You'll notice the point G. Now according to postulate 1, we can construct a line segment from G to C, which I won't do here. Now I want to point out that that is the line segment we are interested in, because line segment CG is the same thing congruent to line segment AB. Why? Well, remember, AB is congruent to BF, radii of the same circle. We also know that F to D has got to be congruent to G to D, radii of this larger circle that you see here. Now remember, this is an equilateral triangle. So here we have a line segment, and we have this line segment, and they are congruent. Furthermore, I've got this side, which is marked as little c, and this line segment, which is marked as D, is congruent. And remember that we have something called axiom 3, that if you take equals and you subtract equals, that what's left is still equal, which means that GC has got to be congruent to BF. Well, I hope this helps you get started on E2. So good luck. Thank you.